Okay, so earlier this week I went to a talk at Harvard by Kathy O'Neill. Have you heard her name before?
No.
No, do you? No, she wrote a book called Weapons of Math Destruction, and she talks about how algorithms, what should I say, so how computers helping people make decisions can sometimes lead to bias. And one of the examples she gave was that in court systems, they sometimes try to predict whether someone's going to be a repeat offender. So someone's in court and the court tries to decide, is this person likely to commit another crime in the future? And studying those decisions, they found that for black people who are accused of crimes, the algorithm is twice as likely to make a mistake as for white people. And so that is some sort of unfairness built into the algorithm. And I want to show you how that happens here. So let's say let's go back and untilt it. And we had something, when this is flat, would you say this is pretty fair?
Yeah.
Okay. So it's flat and things look pretty fair. Now what we're going to say is for, I need a pointer. I guess I'll just use this computer cord. What we're going to do is say if we find somebody in this part of the distribution over here,
Yep.
we're going to say, so this part and to the left. Can you duck down just a little bit because you're casting a shadow? There you go. So this part into the left, we're going to say maybe they're the ones who are most likely to repeat.
All right.
Okay. And what do we do? We flip, and how many people are over here?
Not very. It looks like only like 7 or 8, maybe 10.
Okay, what do you think? How many are over there?
Well, it seems like there's only one here. It's about 3, 2, and then there's maybe like 7 or probably 5.
Okay.
So,
And what do you think on this side?
And then there's like, so for the last 4 rows,
Or 5, or
5.
Whatever approximately. I don't need you to count them. But
it's around 10 or 15.
So you think there's more over here?
I think there's actually less. I'll say 10.
Okay. So
There's
what do you
less.
think in relation to each other on those parts
So-
of the curve?
they should be
Roughly
about
the
the
same.
same.
Okay. No, but it didn't.
Some of the
didn't
balls
empty out.
didn't.
Yeah. Sorry. Do that again.
That's better.
Okay.
So they still look about the same.
Okay. All right. So now I'm going to tilt it like that, and we're going to look again at those edges of the tails. Okay.
All right.
What do you think is going to happen?
I think
So there
there's
should
going to
be
be
more
on
on the left edge and less on the right edge. So yeah, there's
And that was the case.
Okay.
like
so
twice
what-
as many. Maybe 20 or 25.
Okay. And how about over here?
So there's
There's like
only
3 or 4.
Okay. So we said the distribution itself hardly shifted at all, and
But-
you were surprised that the whole distribution hardly shifted.
Didn't change very much. But
Oh.
it changes. If you look at the extremes, it changes a lot.
Okay. So what happened this time? If I look over there.
So yeah, we've got
Maybe 20 or 25.
Yeah.
Okay. And
And
what
then
about
over-
in the last ones
over
over
here
here?
you-
We only have like 4. We've only
4 or 5.
yeah.
Okay. And is this a big tilt we've made on this?
No, the thing we put under it's like maybe half an inch.
Okay. So half an inch. It's probably not even half a centimeter. So it's a tiny little tilt. But all of a sudden, what happened is if you were making decisions based on the edges of this, before it was sort of the same, right? 50-50? And your guess is tilting this just the tiniest little bit. created something. Your guess is this is 4 to 5 to 1 now. Is that what you would say?
Yeah.
Yeah.
How many are over here?
There's only like honestly,
I
there's only like 3.
Okay, and what do you think over there?
I'd say at least 25.
Okay. So it's tilting it very severely. So, would you have guessed that?
No.
No.
Why not?
Because it didn't look, from this distribution, it didn't look like it was shifted by that much over, but when we actually look at it, it seems like if you look at the ends, it shifted a lot.
Okay, and so now, if you saw this distribution here that we have right now, would you guess that was a tilted distribution?
I would guess it was tilted.
Okay, you would. All right.
Yeah.
Would you guess it was tilted a lot?
No,
No.
I would say it was tilted a small amount.
Okay. But when you look at the tails, what's the impact of that?
It's very severe.
It's very severe. And so maybe what I'll do is I'll make it even less severe tilting. We'll see what happens. So I have this, something that came in the mail, and it's just a few pages thick, and I'll tilt it with that. So even less, because remember, as I used Kathy's example, it was just 2 to 1.
Yep.
Right? So I'm going to tilt this now, and you tell me, with just barely tilted now, can you tell from the distribution that this is tilted?
Yes, just very slight over here. It's just
I wouldn't be able to say from this, if I did it a couple more times, because it's only a slight shift, so it might have been just an abnormally. But yeah, it does look like it's shifted, but a really small amount, even smaller than what we had before.
Okay, so let's look at the edges here. What do you notice in this edge here? Is there more?
So there looks like there's more. It looks like 10, 15, maybe
Okay.
even 20.
And what's over here in this edge?
Less, probably not even 10. Maybe like 8.
Okay. And let's do one more, just with this very tiny little tilt. Okay, so there's the whole distribution. What does this end look like?
So maybe 10 or 15.
Okay.
and then that's about.
This is maybe at 10. So there's more here.
Okay, so you think...
It's just slightly more.
All right.
It's
So,
not as pronounced as our previous one.
okay, not as pronounced. So, but yet, this tiny tilt here, which is only, 10 pages of paper?
Yeah.
Shifts it, so you're thinking it shifts it 15 to 10, so about 50% more in the tails.
Wow.
Okay, so what do you think that means about algorithms where somebody's trying to pick like the top 10% or make a determination about whether someone's going to do something, but that thing is already unlikely to happen? What do you
Well,
think that means?
I think that if you're looking at the extremes, I think it shifts it a lot.
Okay, what do you think?
So you have to be really sure of what your data is. Otherwise, like even if it's a small difference, like then it will drastically change the outcome.
That's right. Yeah, and so you can see in this distribution where we've just got the 10 sheets of paper, it's very difficult to even see the shift in the overall distribution, but it's very noticeable in the edges of the distribution.
Yep.
Mm-hmm.
And that's sort of what Kathy's talking about with these
So there you go.
trying to make sure algorithms are fair. It's a very difficult thing because a lot of times they're used for looking at things that are in the extremes, and even these tiny little biases make huge differences in the extremes. So the work she's doing is very important, and you can see from here that it's very difficult. Tiny biases can lead to what?
Big impacts.
Big impacts, yeah. All right. Hey, high five, guys. Good work.